All right, guys, welcome to day 2 of 315. We're going to be covering a few more of these word problems today. So the first one that we're going to be looking at, there we go, is if we change pricing, right? So this is a fairly commonly used thing in the kind of business world of if I increase my price, I'm typically going to see less sales. But that might be good, right? If I see a few less sales, but the amount more money that I'm making per sale kind of more than compensates for that. That's a smart business move for me to make. It also might be the case that if I reduce my price by a little bit, I'll sell a whole lot more, and that'll more than make up for the cost of me not making as much money per thing that I sell. So this is a fairly common way to kind of optimize what's the best price to set for my particular product. So first one here, we have 800 widgets that are selling at $7 each. My research shows that if I increase the price by 50 cents, I will see 25 fewer sales. So how much should I increase my price in order to maximize my overall profit here? So let's take a look at how we should approach this. So on these ones, effectively our income is just equal to the number we sell times our price, right? That's a very simplified way of like figuring out how much money we're going to make. How much we sell versus how much we are selling it for. Pretty easy, right? So this is what I'm trying to optimize. I want as much income as I can possibly get. So the number sold, well, that is going to be 800 minus some number of 25 minus 25 per increase. So I'm going to define x here. I'm going to say that x equals my number of 50-cent increases. If that makes sense, right? It's how many times I increase my cost by 50 cents. So that's my number sold. Then my price, that starts off at $7, right? And I want to increase that price by 0.50 times x, because my number of 50-cent increases times 50 cents, add that to my starting price, and that's how much I'm going to be selling it for. So there is my equation that I can optimize here. So now I could call this y and then try and solve it out, but I really don't have the tools yet at our level to be optimizing these. That's a calculus thing. So we can only really do optimization by graphing it. So we're going to go ahead and open up our Desmos graph and try this out. So we're going to type in our equation of 800 minus 2x, or sorry, minus 25x, times 7 plus 0.5x. Now we're going to be looking at, well, what's going to be our optimal price here. So we're going to go way out and look at where this peaks. I see it right there. All right, so I'm seeing that peak at 9, 6,612.5. So looking back over here, I saw my peak here. Now let's see, well, what does that mean, right? Well, my x in context was my number of 50-cent increases, and my y in context was my income. So I should expect an optimal income of $6,612.50 if I sell my widgets at 7 plus 0.5 times 9. Well, let's figure out, well, what would the actual price be? Because that's kind of what the question is. So if I do 0.5 times 9, I'm increasing my price by $4.50 plus times plus my $7 initial value there is $11.5 per widget. Is what I should sell it at, and I will make that much money. At least I would predict to make that much money off of selling it at that price. Right. So again, another optimization problem. Whenever we are doing those, at this level, the only tool we have is write an equation, graph the equation, find that maximum or that minimum point. Next year in calculus, that is when you will actually find the mathematical way to algebraically find the exact value for that optimization. Okay, so number 67. So this is going to start to introduce us to direct and inverse variation. So there's some flavor stuff there on top, but the meat of it is, right, so we have wire, so the wire varies, the resistance of the wire varies directly with its length and inversely with the square of twice its radius. Okay, so first of all, directly with its length, directly is stuff that looks like this. If stuff varies directly, so we have our resistance varies directly with its length. So that's going to be K times the length. So varies directly just means you multiply it by some constant. This K is the typical variable we use for a constant of variation in some kind. But it's not just a direct variation. It also is inversely with twice its radius. So inversely means we divide, right? And twice the radius is 2r, more commonly known as the diameter. So I'm just going to use d for the diameter, squared. So add that to the second power. So that's kind of what I know as far as this is how stuff varies. My resistance is going to be going to vary by some constant directly with the length, which is multiplied, and then inversely, which is divided by the square of the diameter there. Okay, so we have to do this because every single material our wire might be made out of is going to have a different constant here, right? If it's copper versus aluminum versus gold versus whatever, they're going to have drastically different resistances there, or constants of resistance here. Okay, so you give us a piece of information about our wire and says, hey, when it's 2.4 meters long and 0.004 meters, it has a resistance of 150 ohms. So I know that this has to be 150 equals K times my L is 2.4 over my diameter is 0.004 squared. So now I can use this and find out what my K is. So if I do that, take 150, I'm going to multiply it by 0.004 squared to kind of move that over there. Then I'm going to divide by 2.4. And I get my K equals 0.001. So there's my constant for this particular material that I'm working with. Okay. So then I'm told that I want to find what's the resistance, so what diameter do I need if I want 90 ohms and 1.2 meters long of wire. So I want my resistance to be 90 ohms. My K is still that 0.001 because that is now a constant that I know. My length has to be 1.2 meters. What I don't know is what does the diameter have to be. So now I have an equation of only d as my variable, so I can solve for it. So I'm going to multiply both sides by d squared. 90 d squared equals 0.001 times 1.2. So if I do that, grab my calculator here. Make sure we can see it all. Okay, so 0.001 times 1.2, divide that by 90. I get a pretty darn small number there. I then want to square root it to get d by itself. Second square root of that. I don't care about the positive or negative answer because I don't want, I can't have a negative radius or negative diameter on my wire. So I get my diameter is going to be 0.002 365 meters, if we round that, for how thick of wire that I need to get that number of ohms of resistance on that length. Awesome. Okay, let's hop back over here, take a look at our last one. So this talks about forces of gravity. So again, it's trying to you used to inverse versus direct variation, because gravity deals with both once again. So it's jointly of the two masses of the objects and inversely with the square of the distance between them. Okay, so let's think about what that's going to look like. So my gravitational force, which I'm going to call G, which is the typical variable for gravitational force, is equal to, I'll use K for my constant here, times the mass of the first object jointly with the second object. So that's the mass of my second object. So m is the variable which I'm going to use for the mass. So that K is that constant. And then here's the mass of object 1, mass of object 2. And then that is then inversely with the square of the distances between them. So divided by distance between them squared. So there is my equation that I have, right? So this is, now here's the weird bit, right? They're going to say, well, what if we increase the mass of one object by 20%, decrease the mass of the other object by 20%, and then also we reduce the separation between them by 25%. So that's this kind of last bit here, right? So how does that change the force of gravity between those two objects? So they're purposefully not giving us numbers of these things, right? If you wanted to, you could plug in some fictitious numbers in for M1, M2, and D, and you would be able to get that percentage there. But we're going to do it without even doing that. So let's take a look at what we got. So my new one is going to be my gravitational 2, I'll call it. Actually, I'll use G of n because I want my new one, okay, is equal to that same K. Now my mass of 1, I've increased it by 20%. So to get that, I'm going to do 1.2 times M1. This is the mass of it times 1.2 is a 20% increase in its mass. And then I want a 20% reduction in the mass of my other one. Well, that's going to be 0.8 times M2. Sorry, I'm a little bit crammed there, but we can see it. So to increase by 20% times 1.2, decrease by 20% times by 0.8. And I want to divide that by the distance being reduced by 25%. Now it is not reduced to 25% of what it was. It's reduced by 25%, meaning that there's going to be 75% of that distance remaining. So it's going to be 0.75 times the distance squared. So what I want to find is how does this change in this situation, okay? So I have a lot of the exact same stuff. I have the same K, same M1, same M2, same D. The only things that are changing here are those extra numbers that I ended up adding in. So what that ends up looking like is over here, well, 1.2 times 0.8, 1.2 times 0.8 gives me 0.96. So that's going to be 0.96 times K M1 M2. Right. Then on the bottom, I have that 0.75 D squared. I can square the 0.75 and the D separately. So 0.75 squared is 0.5625 times D squared, right? So now this over here is the exact same as this. So the amount that I've changed is this. This is the factor that I'm increasing or decreasing by, whatever it ends up being. So to figure that out, I'm just going to do 0.96 divided by 0.5625, and I get 1.70666. So 1.70666 repeating kind of deal, right? So this value is whatever my gravity was here times 1.70666 repeating, right? So I'm increasing by 70.6 repeating percent for the same reason that to get to here, an increase of 20% is multiplying by 1.2. So multiplying by 1.706 repeating is a 70.6 repeating increase in my gravitational force. So that is 70.6 repeating percent increase in my gravitational force. Right? Okay, so that is it for these. So note-wise, again, we have direct, joint, and inverse variation. So these are terms that you're going to hear quite a bit, especially when you get into more kind of science type context. Directly means it is being multiplied by some constant. We typically use k for the constant as you are seeing here. Jointly means it's direct, but there's two different numbers there. So x times z, like we had on that last one of mass 1 and mass 2. And then inversely means it's going to be that constant divided by whatever the other part is. Okay. So in that k, again, that's what we call the constant of variation, and that'll be different depending on the situation, but once you find it, it is consistent throughout every problem that is similar to that. Okay, so finally, we're not going to be doing that because we don't have the groups to be doing these gallery walks with. So we're going to be going ahead and moving on to the homework for day 2 of 315. That's going to be 77 through 84, and I will talk to you guys next time.